Hello everyone, in this video we are going to continue the recipe topic and I will show you something very interesting. Previously we have learned how to write recipes for packages that don't have any build system, packages that uses GnuMake as its build system, and also packages that uses CMake as its build system. As you can imagine, there are many more build systems that you might need to cover during your work with the OpenEmbedded. I have simply created this basic online tool called Goyokto that you can use to simply create recipe skeletons, and I will be showing that tool to you in this lecture. Just a little bit of disclaimer, I don't make any money out of this tool, I don't run any ads, I use it myself to also remind myself how to create recipe skeletons for specific build systems or build configurations. I just want to introduce the tool to you so that it can also help you start creating recipes as well. Also, the tool is only informative. It does not always generate a recipe that works out of the box, although sometimes it can. So we might have to do some tailoring after obtaining the recipe from Goyokto tool. And Yocto and OpenEmbedded evolves too quickly, so some of the outputs might be incorrect, but as I notice the mistakes in the tool, I continue fixing them. And without further ado, I think we can start already. So the domain that you can use to enter this tool is given here, yoctoproject.net, and you are simply welcomed with this page. So what all this means, I will explain. At the left hand side you have this panel that simply prompts you to enter some information, and at the right hand side we have the recipe output, sort of like editor, and it will show us the recipe output. At the top hand side we have some easy access to some of the most used variables, in my opinion. So you have access to your package name, you have access to source directory, destination directory, build directory, and yeah, include library and binary directories. You have the option to access this conditional. Simply we have already learned this. If this variable is simply containing this text, then it will write xorg. If it's not the case, then it will write empty, and you can simply use this sort of conditional directly inside a variable. We have already talked about this. And then you have easy access to your work directory, staging their native and target. As you can remember, we have already talked about this. Staging their target you can use simply to navigate to the recipe sysroot folder or sysroot for the target, and this variable staging their native or staging their host you can use to simply navigate to the recipe sysroot native, so our native sysroot. And also you have this bb-warn statement, although I haven't used it yet. You can use this to simply print out some paths if you're not sure in your recipes or in your task descriptions. At the bottom we have how to use, just some textual description. You have the option to reset. This reset will simply refresh the page. You have the option to save the file, but before saving it to file, it is throwing some error, making sure that okay, some of the fields must be set in order to correctly generate preliminary recipe output so that we can save. And then we have the option to copy to clipboard simply. And let's explore what is inside these this sort of prompts. First we have the preliminary information. Alright, we will give our own name, email, and some of the package related information here, package name, package version. And as you can see, when I select some field, it is giving me some information. For example, it's saying enter package name in lowercase, for example, libmytool. And then we have the syntax style. Syntax style is important because Yocto recently, after the branch Honister or after the 3.4 version, changed its syntax. So for example, when we are appending to a variable, we were using this column, right? So we are using something like this, in order to append something, but before this wasn't the case. Before we had to use this underscore, and the column is the recent syntax. So you have the option to actually select between the old syntax and the newer syntax. Of course we'll be using this newer syntax. Then you have some licensing prompt. When you select some license, it will give you how to fill up these license and license field checksum as an example. Although I have found that sometimes you have to specifically give this common license to their path because it doesn't work in some of the versions. but yeah, we will be using closed license for now. And then comes two fields, runtime dependency and build time dependencies. For the runtime dependency, it will simply fill in the rdepends variable, and for the build time dependency, it will simply fill in the depends variable. And as you can see, we have also some directive given to us left hand bottom side, and a list of space separated build dependencies, for example bash space qtbase space libusb, for example. We have the option to select the source type. We have access to three types. First is the local folder or file, and you can see that it is directly using this file inside the source URI variable when you select this. And also you have the option to simply give the folder to extend this source URI search path using your own path if you are using some local path for the source. And we have also option to select git. As you can see, these two variables are filled in, and this git header is used simply. And if I type in something, it will be also filling this one as well. And finally, we have the option to give tar archive or tarball as a source. It will simply fill in this source URI with sort of the URL that you give. And one thing that is important to mention, if you are using a tar archive for source URI, simply you have to also specify two hashes, MD5 sum and SHA-256 sum. And the tool that I've developed has the option to simply generate these two as well. So if we give indeed a valid file here from online, I will demonstrate this, it will be generating these two hashes also. Let me tell you that if you don't give these two, Yocto will throw an error and suggest these two sums by itself, so you can also copy from the error line, so you don't have to rely on this tool. Alright, next up, our most important feature is to be able to select recipe type. We have explored three. We have explored GNU-make, CMake, and some basic C compilation. You can notice as I select the recipe types here, then the sort of DB class that is inherited changes here. So in the case of CMake, package config and CMake is inherited. For example, if I select something like QMake, then yeah, it is requiring or inheriting some sort of other file here. And if I select the GNU Auto Tools, this one is used, Auto Tools VB class. And I have the option to also add these pip packages, Python pip packages, by using these two. And these uses simply two classes, PYP and setup-tools3, for example, for this case. And I have the option to simply use CMake for the Qt6. This is one of the recent additions that I did to this tool. And you have option to simply create a kernel recipe or kernel module recipe. Okay. So as you can see, if I select something, I have the ability to add some additional make flux, this variable, this field here. If I select CMake, I have the option to simply add some CMake flags using this extra or a CMake variable. So this is very versatile tool that is specifically helping you create and sort of gather recipe for these type of recipe types. On top of this, you have the ability to simply add append statements to your already available tasks. You can select these ones and you can fill in these optional fields in order to sort of fill these. And what we have also is integration to the init system. So if you have a script that you would like to run during the system boot, you can simply attach it to the system5 init system by sort of filling in this detail. And you have the option to create a systemd service. Based on this, you will be asked to simply include the systemd service file name, and you of course need to provide the systemd service. And we have the option to provide C compiler flags. We don't have the target and host separation, so usually by using some distinction here, we can separate like so flags that we can use for target builds and host builds, but we don't have the separation. This works for all of the cases. So for example, I will be able to specify, define this variable, select this optimization flag and make it debuggable. For example, I have option to simply enter this one. And final things, I have the option to also add a machine constraint. What this means is basically you can make a recipe run only for a specific machine. For example, in our case, our machine is Raspberry Pi 5, and here I can type in Raspberry Pi 5, and this recipe in this case will only work for the case machine set to Raspberry Pi 5 in my local conf. For any other case, if my machine is set to something else, then this recipe will not be simply available for me to use, and if there is no other recipe in any of the other layers, then Bitbake will throw an error saying that, okay, I have found one recipe, but it is not compilable for your machine. This is the compatible machine statement we hadn't seen before, but I think it is good to mention it. We have the option to use this pipe operator and simply give other machines. So we can make our recipe compilable for only Raspberry Pi 5 and Raspberry Pi 4, for example, in this case. Alright, so we have also something called a feature constraint. Although we haven't mentioned it before, OpenEmbedded comes with these predefined features. With OpenEmbedded in our local conf, we can define another variable called distrofeatures. Distrofeatures is just a variable containing the feature names. You can think of features like collection of stuff to include in your image or additional configuration. Features generally are used to encapsulate big features on Linux, such as X11 support, WLAN support, keyboard support, Bluetooth support, NFC support, OpenGL support, hypervisor support, and so on. In your local conf, you can enable these features by appending to the distrofeatures variable. The configuration in the local conf is just one part of it. Now, the second part is restricting the recipe names based on the values in the distrofeatures variable. Here in the recipe, you can restrict your recipe to only work when certain features are enabled. For example, if I say that this recipe requires certain distro features, then this recipe will only be usable when that distro feature is enabled from the local conf distro features variable. Although not very common, we sometimes also have to specify certain required distro features in our recipe files. This option is also in GoYocto tool, which enables you to configure that variable. For example, in the line 14 here, we set required distro features to X11, WLAN, OpenGL, and virtualization. So that is basically X11 support, WLAN support, OpenGL support, and virtualization, which is the hypervisor support. Although these can't come together, it's not realistic to have X11 and WLAN at the same time. Let's imagine that, okay, we set our distro features to these 4 features. This makes my recipe only valid when I add to my distro features variable these features in my local conf. So for example, if I say something like this, required distro features append X11, then this means that this recipe file will only work if I have in my local conf the distro feature definition for the X11. So how to add that? Let me just quickly demonstrate here. Distro, sorry for the mistakes. For example, if I have this one, then my recipe file will function correctly. If I don't have this one, then it won't be working correctly. Alright, let us continue. Let us reset and let us create a simple example. So in this case, the example I want to give you is regarding these pip packages. So as you might know from your previous experience, in order to simply install some Python packages, in most of the distributions we have this tool called pip, and we can simply install Python packages by using this pip install command. So something like this, for example, pip install, and then you give the Python package name, right? This pip is simply Python package manager. It is a package manager on its own, and luckily with Yocto we have easy access to simply install Python packages also, because since our image will be an embedded image, we will not have the ability to use this sort of package managers from shell. Yocto has this BB class so that we can simply install will outputs into our image. Alright, and of course you can also simply install Python 3 packages using this pip3 command. I haven't mentioned it, but so I've already found one example. So for example, you have a dependency to a Python package. First you go to this pypy.org and you can search for the package. what I want to do is I want to simply write a recipe for this Python package, and I'll show you how easy it is with this tool. And this is not only for Python packages, but you can experiment with other sort of recipe types we have. Alright, so it is first asking me my name and my email. Of course, these fields are optional. I don't need to give it, but let me give it, let's say email, alright, and my package name. So the package name will be called Python 3 ASCII, since I will be developing a software package for this one, and the version will be 3.6. Okay, and let's give some summary. Recipe file for ASCII package. For the syntax style, we are going to be using this host 3.4, of course, because we are at a later branch with this card gap. And then licensing comes. If you are publishing it, it is important, but in my case, I won't be publishing anything, so I'll select the closed just for the sake of simplicity. Then let's move on with the software package dependencies. I'd like to leave these fields empty, as I'm not sure yet regarding the dependencies. I might fill these based on the errors I get. But let's check briefly if there is anything written regarding the dependencies. It is not, so let's leave them for now. If we get any errors, then we will revisit these. Next up, I have source type and location. I can simply select tar archive because I know that these sort of Python packages have tarballs available, as you can see here. ASCII 3.6 tar.gz, it is compressed tar, so I can copy the link file. Simply if I click this, it will start downloaded, but I want the Yocto to download it, so I will paste it here. And as you can see, it automatically generated the MD5 sum and this SHA sum because the file was valid. This is good for me, and it has set this sort of source directory because we know that the source directory will be sort of unpacked version of this, and unpacked tar archive will have this in the folder name. So we already know this, and the tool is also able to help us with that. Next up, we need to select recipe type. Let's select the PyPy Python 3. Okay, and once we select it, it has inherited two BB classes, and it has filled in PyPy package for its own compatibility. And then we can skip the task extensions, we can skip the init scripts or compiler flags or anything else, to be honest. Alright, so we can now save the file, and file will be saved, but for me it's easier to simply copy the clipboard and create my own recipe file. So let's go ahead and do this. First one, let me create one category, which is recipes-Python, and inside I'd like to create a folder with the name Python 3 ASCII, and inside we will be creating our recipe file with the same name, Python 3 ASCII underscore the package version .bb. And inside I will be simply pasting all the content. I think this looks good. I don't think we will have any errors, but let's check just in case. Oh, as you can see, we didn't get any error. It worked perfectly for this Python package. Of course, it's not the case for all sorts of recipes. Sometimes it is more complex. You might need to add some stuff, but I think this is a really good reference that you can use. Alright, and let's simply check the build output, and then we will conclude. Alright, so this is the build output, our work directory, as you can see, and let's see the image, what is deployed first. As you can see, the Python files are deployed under site packages, so it is already correctly integrated and configured inside our image or inside our package feed. I'm expecting the same. Yes, it is the same, which is good. And what more? So we have our source here. Just for the sake of showing it, you can see it here. That is also good to see. And I don't have anything to show actually. Alright. I think this was very interesting lecture. I hope your opinion is the same. We learned about this tool to create simple Yocto recipe skeletons. We learned how to create recipes for Python packages. While exploring the tool, we learned about some of the additional variables that are used in developing recipes. So thank you very much for sticking with me thus far. I really appreciate it, and I will see you in the next video.